Well, welcome back. Like I said, two more sessions, but been really excited about this next panel. One of the things as we curated the day today, we really wanted to look at different materials and different systems. And this panel, I think, will kind of bring those conversations together. And we're primed and ready to go with our panel here, but led by Juanita. And Lauren and Bill are also joining us to share thoughts about material trends in design and construction. So Juanita, I'll let you take it away.
I'm just going to start us off by introducing Lauren Van Rieken to kick us off.
Hello. I am Lauren Van Rieken. I've been with Harmon for about 10 years. So Harmon is one of the top leading curtain wall contractors, glazing contractors in America. I've worked for Harmon all over the country and, well, North America, I guess, all the way from Baltimore, DC, Charlotte, North Carolina, Toronto, Canada, as well as Chicago right outside. So I'll tell a little bit about some of those jobs next. Got it. All right. So this one job, 160 Front Street, this is in downtown Toronto. This has a lot of great architectural features to it. Every curtain wall unit is I would say, kinked back. In Canada, they call them hockey sticks. But every glass is at an angle as it goes up. And the building starts at a base and it gets wider and then it comes to the top. And as you see at the top, it also curves back as well. This was a really unique architectural project, pretty challenging. You can kind of see in the drone video how it curves backwards. And there was curtain wall units that were 25 feet wide, 16 feet tall, and 14 foot in depth. So this took a massive team of engineering just to figure out how we were going to build it in the shop, how we were going to truck it down to the job site, and then how we were going to lift it with a tower crane all the way up to the top of the building. So this was a pretty unique project in Canada that Harmon has worked on. Another project in Canada is 81 Bay and 141 Bay. These are twin towers that mirror each other. We finished 81 Bay back in I think 2019, and we're just getting to the top of 141 Bay as we speak here. We're infilling the hoist bay right now. So this is a really cool feature project as well. Once again, there's a lot of diagonals. So they have this faceted diamond-shaped curtain wall that goes all the way up and has really great features. At the top, they have heated glass that helps melt the snow and the ice and stuff in Toronto as it's cold and snowy. And there's some skylights at the top really too that create a really nice atrium. Another one in Canada, across the way, they basically took 141 Bay and turned it on its side. So, this is a 10-story building, but it has that same diagonal feature. And this has really reflective glass. So it's actually really cool because and this is going to show the best fit picture, but it actually reflects and shows all the clouds in this building. So it's a really cool feature as well. Just another little project we've done recently. So getting to our Chicago jobs, some of the ones that I've worked on myself is Salesforce Tower. So Salesforce Tower, as you walk outside, you'll see it. It's a beautiful building for the Heinz and Kennedy Group. It has this beautiful structural glass wall at the base of the building. So when you leave here, just walk over there and just check it out for a little bit. But what you'll notice, and I don't have a really great photo of it, but it's all glass. So it's all glass. There's structural glass fins that are actually hanging from the top that stop 13 feet above finished floor. So when you're in that lobby, you look out, you don't see any structural features. There's a little bit above you, right? You got to look up and you'll see a glass fin, but it is crystal clear when you look out, which really gives nice views of the river and, really get to see Chicago in its features. So Harmon did the structural glass wall, we did the curtain wall, we did the column covers on this job, we did the soffit panels, everything that you kind of see right there. And then it also has a really cool top as building as well. And I was actually telling an architect the other day that we were halfway through building this building when Kirklis and Ellis signed their lease to join on as partners. And as we were halfway building this building, they were like, "Hey, we want to add 5 floors or 5 feet to the building, so our executives have taller ceilings." And I went back to my design team and I was like, "We got to price this," and they're like, "We're in the middle," and I'm like, "I know, like it's gonna be okay, you know." And we were able to actually add the 5 feet during the building of the construction, so that was actually really cool. An expensive change order as well. Um, and then the other one is Wolf Point East, who is another job that is dear and near to my heart. And some of the architects that I've worked with are actually here today. But this was a fantastic building as well, also right next door. We had over 2,000, you know, zero sightline vents. It has these nice architectural features of these 3, 6, and 9-inch deep vertical fins that give it kind of the slender view, as well as these horizontal feature bands on like every third floor. So it has this really beautiful views of, you know, kind of get to see that big white building and crisp. It also on level 3 has a structure or a pool, and it has this big 85-foot wide sliding panda door as well. So these are just some of the highlights of jobs I've currently worked on with Harmon. And then I'm going to turn it over to Bill next.
All right. I'm Bill Zahner. I'm representing the Zahner Company. We're architectural metal company in Kansas City in Texas. We work all over the U.S. And what I want to talk about, just to briefly introduce, some of the things that we do. One of the aspects we've gotten into is how do we modify the surface of metals so they can be used in a sustainable fashion. They represent materials that are more on the natural basis, such as darkened steel and substances like that. So we pre-oxidize the surfaces in our Texas facility. And we work with all metals, so the various steels, the weathering steels, we pre-weather, so we reduce the amount of runoff and waste conditions that come off the surface, so that when we put it up for the designer on a building, it's something that is going to stay that way and not stay in the adjacent areas. So we engineer, fabricate, and install a lot of the work that we're involved with. When we manufacture this stuff in our Texas facility, when we put the finishes on, we recycle everything. We capture all the effluent and return it back to be reused and capture the metals out of it. But we work in copper, zincs, the steels, and we have kind of an ongoing process of developing more. And if you go to our website, you'll see some additional surfaces that we're working on. Some we work on in conjunction with different design firms to create something rather special and unique. So we combine that with our fabrication, our state-of-the-art fabrication, which is, so we take these things that were usually sent for art and move them into the more commercial basis. So we use robotics in both the field and shop to assist us in the fabrication, mainly to speed up the delivery, keep the accuracy, support the systems that we're constructing. We also do a lot of modularization, and it's kind of our answer to the issue with workforce conditions out there. Is if we can make it in our plant, we control the quality, we can get a lot of it done so that when we install it in the field, there's less activity and less time in the field, and we can get the accurate results that we're after. The other aspect, we enjoy working on buildings that we consider generational, those that are going to be enjoyed by generations to come. So we use materials and processes that last as long as we possibly can. So we enjoy working on really good design with materials that's going to be sustainable for a long duration of time for generations to enjoy. Thank you.
Thank you. And I'm Juanita Garcia with Pepper Construction. I've been with Pepper Construction for the last 6 years. I joined the high performance and sustainable construction team at Pepper with a focus on carbon drawdown. So a lot of that has been focused because of understanding that call to action, knowing that over 40% of carbon emissions come from the built environment. A lot of the carbon drawdown strategies that we were employing at first were really focused on operational carbon and how much we could influence clients and work with design partners to draw down that carbon to reduce carbon emissions. But, the thing about carbon emissions over the life of a building and operations is that they're emitted over the lifespan of the building, whereas embodied carbon is emitted into the environment before it's even installed, right? So it's the carbon emissions from the manufacturing of the materials. So with that, the last year, Pepper has been focused on developing a baseline of our internal projects of the whole building life cycle analyses of buildings. We started with 60 buildings over the last few years across our offices, but we started to look too at the industry and where we're at and what has already been published and what has already been shared. And one of those, earlier this year, the Carbon Leadership Forum published a benchmarking study that had a much richer group of buildings, just under 300 across market types, geography, and project type. So with that information that they published, we were able to see some really interesting data, right? So with that, we're able to see, this spread of embodied carbon across these three different material building and element types, right? And we knew that structure was going to be high. We knew that, we anticipated that, but it was really interesting to see this spread across this almost 300 buildings and how much they varied across market type and size. And once we started to look at that embodied carbon intensity, so we knew that the enclosure was interesting. We started to comparing that to the projects that we've been working on. And then also seeing how much, once you start breaking it down into specific materials, we anticipated that, carbon and steel are really high embodied carbon because of the manufacturing process. But so this is something we've been looking through and really been really thinking about and how much we can help influence that in our projects. And this again is coming from that Carbon Leadership Forum study. And then just as a touch point with a project that we're currently working on with Smith Group, there is a project in Racine, Wisconsin that's pursuing LEED Platinum and net zero. And one example of a material, although it's not, one of the biggest contributors, but as we start to think about those opportunities to start swapping materials and look at opportunities to reduce embodied carbon, this is one of those cases where a rain screen initially was going to be porcelain, and because of some issues with lead times, we ended up going with limestone. And this is one of those cases where just swapping out that rain screen, that one material alone, just kind of going through industry standards, was a quarter the embodied carbon by square foot. So there is that. With that, I'm going to transition into asking our panel a couple questions to talk about, sustainability from a manufacturer's perspective. So reflecting on the current state of the industry, do you see growing demand for sustainable materials, and what are the challenges to those impetus to change those materials?
I'll give it a go here. These metals are often a target on some of that aspect. And what we look at in the materials that we work with, they're all the full life cycle of the material. Metals are the only material that can be used in construction that can be recycled endlessly and returned to their original characteristics, physical, mechanical properties. Now, saying that, when they first arrive, they do have levels of embodied carbon, but every subsequent use is usually, particularly aluminum, it's like 95% of the energy usage on recycled aluminum is reduced. So you actually have kind of like a mining condition in the sense. Secondly, there's a huge market, an industry as such, that are involved with recycling the materials on metals. I often say that the Young Museum in San Francisco that we did, there won't be a single square centimeter of that copper that's going to go to the waste dump. It's going to be reused and reused and reused forever.
Hey, Lauren, you have something to add?
Yeah, I think it definitely, as architects are trying to choose metal or choose materials, they're definitely looking at the sustainability of the material. And, I think a new thing in the industry over the last 5 years really has been the EPDs, the environmental product declarations. And, and really trying to understand the full life cycle of the material and what it's really doing, and the energy it's giving off for that.
Can you talk a little bit about the challenges with those EPDs?
Yeah. So EPDs, I think overall some of the larger vendors are very knowledgeable about it. They're ahead of the curve. They have all the information to provide to really look at the full life cycle. However, when we're looking at small, hate to say it, hate to say the tariff word, but as we, looking at tariffs and then we're starting to look at some more domestic, smaller material vendors, some of those are maybe struggling a little bit on getting good, accurate EPDs. And Harmon, I know, has been having to hire some consultants from time to time to really help us fill out the EPDs correctly. So,
Okay.
Just add a couple of things on that real quick too. I mean, it's really important that they have accurate information, and I've found that some of the information that gets into the EPDs lacks some clarity. And I hope that, as designers, you dig deeper into those to make sure you understand the clarity of some of the information within the EPDs.
Thank you. There have been, we've talked a little bit about before about some innovations in your organizations to contribute to sustainability. Can you talk a little bit more about that information?
yeah, I know in our manufacturing plants, we've done a lot of energy resources there or looking at that and, going to full LEDs in our manufacturing plants, right? Overall, kind of small, but still a big picture when you keep the lights on 24 hours a day, and all that kind of stuff. We've also been looking at peak energy times and management as well, right? Making sure, when we turn on the machines, what does that look like if that during the peak and just our manufacturing plants are really trying to understand all of the energy that we're outputting right now. So I think you have a good story.
Yeah, when I talked about the patination of different metals, one of the things we implemented was a reverse ionization process where once we do the patinas on the surfaces of the material, we gather all the effluent. And 10 years ago, we were producing 160,000 gallons a year that we had to take to a special facility to treat the water. Today, by using the reverse ionization, we convert that 158,000 gallons to 28 pounds of solid waste that's metal that we then send back to be recycled. So it's something that we've been recognized by the EPA in Texas, but it's just the right thing to do. And it actually saved us as a, capitalist, it saved us a ton of money. You think of having 158 gallons you got to put onto a truck and haul to a different place. Now 28 pounds. It's a huge difference.
Yeah, and the waste story, right? The reduction of waste that input that could be used.
Absolutely. And we reuse the water.
Yeah. Okay. And this, did you have something to add?
No.
Okay. I guess looking ahead at opportunities for innovation, have you identified some and thought about some opportunities in the future?
Yeah, Harmon's been looking a lot in robotics. So robotics both in our manufacturing and in our field operations. We've tried out some robots to do field layouts and field installation of anchors and things like that. So, it's not, I don't think, fully ready to implement yet, but hopefully in the next 5 years, I really think, you're not going to have a layout guy. Everything's going to be, you're going to have a little, like the little Roombas that mow your grass, you're going to have Roombas that go around the job site, laying out, scanning all the stuff, putting all the lines on, this is where the stud walls go. This is where the curtain wall anchor goes, right? So I definitely see that coming in the future for construction for sure. And then I think Sealy did a great job showing how their automated robotic, manufacturing plants. That's definitely something that's coming to the curtain wall industry as well as having a fully automatic Erdmans, the glazing machines that are doing the caulking, as well as yeah, I think Sealy had a good photo of the automatic robotic CNC. So not just a CNC that's just going to drill holes and cut your parts and all that kind of stuff, but now there are CNCs that are loading the parts into the CNC machine, doing all the fabrication, and then outputting it as well without a single person touching it. So those are definitely like the manufacturing stuff is definitely something that is going to be started to be implemented here pretty soon. So
One thing I think is low-hanging fruit, packaging. We all go to a job site and you see as the project's going away, there's just an enormous amount of waste, packaging waste, dunnage, things that we were using to protect the materials on delivery. When we did SoFi Stadium, we shipped everything in like pizza boxes in a sense, and those were all then broken down and recycled, put into a pallet, sent back. There are ways, if you plan it out, I think that you can deliver your product to the site and get it installed where you don't increase this tremendous amount of trash waste. One of the things that we're really trying to do at Zahner is figure out how to get rid of I hate, hopefully not here, the Nitto film, which lasted several centuries. If there's another way we can protect our material, we got to get it to your job site in a good fashion. But how can we reduce the waste?
Okay. Then also we talked about the opportunities too for as we look ahead to projects and you both shared some projects that you've done recently. Can you talk in a little bit about some sustainability wins that you were able to have as a project, as a project team, because of a collaboration that you were able to share a sustainability win?
yeah, right now Harmon is working on Northwestern Mutual out in Milwaukee, which is a reclad of a building. So basically they took off all the old facade and all new facade is going on. They poured some slab edges, so it's a whole different shape of a building. It's actually matches their existing building that they have up there. But they were able to recycle. The GC, I know, was able to really recycle almost all the material they pulled off, which is really great. And I think that's really showing how do we take the buildings that we have today that have good bones, that have, the structure, and how do we make them new, right? How do we make them better energy efficient? How do we add better glass? How do we give them better thermal requirements? And I think the Northwest Mutual project is just definitely doing all of those things. So.
At our facilities, we really concentrate on, again, reducing the waste issue and changing and constantly kind of building upon that. But, one thing I have to applaud the architects and the push to sustainability. I speak and talk with a lot of industry folks in the stainless steel industry and in the copper industry, and they're listening. And so like there's a mine, I want to say, going up in Canada, new nickel mine, for instance, where they're trying to make it carbon negative. So you think, how can a mine be negative? And it's because they're crushing olivine when they're recovering the nickel out of the ore, and the olivine captures carbon in the air. And so they wouldn't even talk about this 5 years ago. And now I think it's become something that's gone all across the industry. And I think it can be applauded, and we keep our mind on that. You're going to see some nice advances, I think, coming out.
Okay, Juanita, put your panelist hat on. I'll take over the moderating duties. We good? So we're going to open it up to audience questions. A lot of them are starting to trickle in. So thank you for a great discussion. Let's start with the top. How's your company approaching the move to circular construction?
I could kick us off on that. I know we've been thinking a lot about materials in demo and how much there's any existence of any extended producer responsibility opportunities. I know we've talked to, in addition to being able to recycle materials, is there an opportunity to we've been working on this circular economy. We've really been trying to tackle it and really been trying to think about materials in a different way, and are piloting a project internally on a project where actually one of our own offices, and thinking about that. And they're like, if we can make it happen, when we're the owner and we're the GC, then how do we replicate this and scale it on other projects?
Lauren and Bill, you both touched on this a little bit. Anything else you want to add?
Just as a metal company and having to sort metal when I was young, we recycle everything at our place. I mean, it's really a big, but it's now we're moving it to paper, wood, other materials, and plus the materials we use, we can sometimes request that it has a high recycled content.
How is the landscape of material suppliers changing in North America? It doesn't say that word.
No, I mean, I think overall it's really developer dependent right now. Some of the developers are still really wanting the European products, and they're willing to, set aside the money for the current situation to do that. And then the other ones is, they want the North America products. They want to use North America vendors to try to keep everything, here. That's what I'm saying.
We're here.
Well said. This next one kind of ties into this as well. But how do you think the industry can be more flexible and maybe nimble with regards to tariffs?
Ooh. I know one of the pushes we've had with the tariff conversation are like, well, is this an opportunity for reclaimed materials? Is this an opportunity for materials that already exist, don't require to be remanufactured or shipped with tariffs from other countries? And also thinking too, like how much transportation is part of that embodied carbon story, right? So that's something we're thinking a lot about, and we're anticipating, talking with our design partners on that.
Yeah, and I think there are a lot of great domestic vendors that that have material to build buildings. So, honestly, it's a great thing to try to support those businesses and partner with them. And we've used them and continuing to use them and seeing where they can take their product to the next level as well.
From the metal standpoint, I mean, there's been a kind of a lack of real production of the base metals in the US, but we're seeing people like Nucor and others, from our steel standpoint or weathering steels, step it up, and others. We're really not having that difficult of a time. We're seeing prices go up because when tariffs came in, the domestic suppliers raised their prices too. So, but we're looking at ways of, maybe reduce the thickness of the materials, change the way it's done to bring the cost per unit area down. It's something that needs to be kind of work its way through a little bit still.
Maybe just an add-on to that though is, I mean, presumably designers in this room are making decisions about material selection specification based on reality or perception around tariffs. Are you seeing that?
Yeah, like I said, I think it really depends on developer dependent. Some of them are saying, "Hey, I don't want to talk about tariffs and don't, all domestic." And some are saying, "Hey, that we can talk about it." So right now we're seeing it being developer dependent.
For us, we do a lot of design assist. We work with the designers very closely, and we'll work with them on figuring ways that we can reduce the cost effect that maybe a material has that's gone up in price, Some of the copper alloys are up, 30% almost. But we'll work with them on ways of reducing certain areas of cost so that offsets whatever the increase in tariff is. We'll go for that budget and without sacrificing quality is our general approach.
Let's move on, shall we? I like this one. What's changed about the relationship between project delivery methods and the partners on a project, say, over the last 5 or 10 years?
You got it? Yeah. Well, I think that collaboration really is great because it's allowed us to identify those opportunities early, especially in sustainability. I think when you have everyone thinking about that, and all the experts, all the stakeholders are experts in their field, and they're able to identify those opportunities in a way that other project team members wouldn't necessarily be able to. So that's been really exciting to see, like how much the overall projects get to be more sustainable. They have a better impact, and wherever we can, reduce the costs and still be able to have those sustainability wins.
I think also, I mean, I feel currently right now, there's a little bit of shift of pulling in design partners really early. Like we've done design assist for 20 years, right? But there was a shift where it was really early on, and then they kind of backed off because I think, schedules were going so fast. And now again, schedules are we got a long time for schedules again. And so people are bringing on those early design assist partners, and we're really able to work out those details early on to really get a good design, like Bill's saying, coming up with better ways of doing things when you have your sub on board and, the experts at, that. So I'm seeing bringing the design partners on early on.
And probably another big change, I think, is integrating the digital definition of a project early on in the design development and design assist, because then you're able to work the physical piece almost. And we do a lot of prototyping so that there's no mistake in what we're going to provide to the client. I often say it also does our people good because they see that this is the absolute worst the client is going to see. If they like this is the absolute worst they're going to see. So this is our baseline, and connecting that with design assist is a huge aid for us.
Keep unpacking that a little bit. I'm going to spin that into the question about technologies to collaborate with designers, but you share a little bit more about that.
Sure. When we work with a designers, usually even the owner might even be involved. We'll do a design assist mode that incorporates the solid model, computer model, and then we may work with what materials are best suited for that. But we'll also do small prototype or mock-ups, and then we'll do a large prototype because that shows how it's going to go together. We can budget down the cost. We get rid of all those hidden things that might show up. There'll still be those, but at least you start taking that down further. Our approach is to do it so that they know what they're going to get. And it's important to us.
Yeah, I think obviously with BIM is a big thing, right, early on. And, I think I'm just going to say my 2 cents here is, I think Kingspan was talking about the different levels of BIM, right? So BIM 100 versus BIM 400, big difference. However, early on, even a BIM 100 is just, it's good enough, right? Not maybe you want a full BIM model at the end of the job, but you could get that to the level 300, 400 after approved shop drawings and all that kind of stuff. But just early on, BIM, getting the shapes, getting the models going is a big thing. The other big thing that we've started seeing in design assist meetings is 3D printing, right? You can actually, we're struggling on how this is all going to connect and how it's going to attach. Well, you can 3D print almost everything now and come up with that, right? It's not 100% perfect, but it starts early helping the whole design team to understand how things are going to fit together. So those are other things that we're seeing.
Juanita, the way I understood your carbon tracking, it was kind of like post review, but are you working with designers to do kind of more real time design carbon impacts? And can you share any more about that process?
Yeah, that early BIM model can help at least start the conversation around embodied carbon. There's so many tools now that allow us to do that. And, having that Revit model, having that 3D model and running it through, a tool we use, one-click LCA, that helps us start that conversation and start like identifying those materials that really are going to have the most impact. And like that helps us decide to, as a whole team, where do we target reducing that embodied carbon? Where are we going to have the most return on that investment in reducing that embodied carbon?
Thank you. Just a couple more minutes. I think that's actually was the first question submitted, but I'm going to go down the middle here. What makes you most hopeful? Oh, the question disappeared. What makes you most hopeful about our industry, or what are you excited about? Keep dancing. Happy hour soon.
Almost soon. I'm really hopeful. I'm excited for the future. One of the things that we've even started is trying out is like GoPros on hard hats, right? And we put it on an intern and they walk around the building and you get this full model. It helps with, especially with the MEPs, the things I've seen that GoPro do compared to the real life, what's there. And then, the BIM models of the MEPs is incredible. For the facades alone, though, it's helping us with like punch list and certain things of, hey, if you have an intern walking on the job, they might not see everything, right? So someone else can be looking at that and then see, oh, there's this issue here or whatever. And it kind of allows you to be able to see a lot more on the job than just the overall photo webcams, which we all have seen on jobs as well.
I wish I was young again. Because I think there's so many things that are happening. I mean, I think when artificial intelligence starts playing into some of the things we're doing on how you package and ship materials, there's so much in the technology that interfaces into helping deliver to your projects, to the designer's projects, and that's tying into robotics and fabrication and installation. Probably in a couple of years, you're going to be talking though about artificial intelligence and how it's benefiting some of the aspects of design and construction, but it'll never take the place of good design. And I think good design, you're just seeing some of the work you showed this today were fantastic. But I'm hopeful just because I think there's a lot of young people that are pretty darn smart and fun to watch.
Is that the first time artificial intelligence has come up today?
Is it?
I'm shocked.
From the old guy.
We got there. Now we're playing the AI drinking game. All right. Juanita, what are you excited about?
Yeah, I totally agree with the opportunities for AI and technology to enable us to do better. Like Bill said, there's some things that are just not going to take the place of human design, and how much that'll just help us build better, design better, and reaching a level too where we're also using data more effectively to understand what we're building, understand how we can build a built environment that's better overall for all of us, and a level of data transparency where we understand better what that impact is.
That's great. I think that's all the time we have here, but I want to thank you all for the great dialogue. So a round of applause for our panel.